All right, everyone. So today we're going to talk about the algebra of functions, or using algebraic operations on functions. So this time we're going to talk. In this lesson, we're going to talk about how to perform algebraic operations, addition, subtraction, multiplication, division on given functions, and then how to determine the domains of these functions generated by these algebraic operations. So let's just start by talking about adding two functions together. Given two functions, two different functions, for example, in this case, f of x and g of x, it is possible to perform mathematical operations on them. For example, a function representing the sum of f of x and g of x will be written as f plus g of x, and it would be equal to f of x plus g of x. There's two things I want you to notice here. First of all, the name of the function f plus g tells you what to do with the two functions. So the name of the function f plus g just tells you to add the two functions f of x and g of x. Secondly, when we read this statement, it says f plus g of x equals f of x plus g of x. Meaning the first x in this equation, this thing you see written here, represents the name of the variable in the function. This f plus g of x is just the name of a function. It's not multiplication. You're not distributing in this case. It's just the name of the function, f plus g of x. So the other operations, as you can see here below, f minus g of x is just f of x minus g of x. F times g of x is just f of x times g of x. And then f divided by g of x is f of x divided by g of x. Remember that in this case, you cannot divide by 0, so if g of x cannot be equal to 0. So when we're given discrete values for x, when we're told what number x is, we can figure these functions out by just plugging the numbers into the individual functions and then performing the operations on the answers. So for example, if we're given f of x is 7x minus 2, and g of x is 2x squared minus x, we want to determine these next four things. Well, let's start with f plus g of 1. F plus g of 1 is just f of 1 plus g of 1. So that means we're going to take 1 and plug it into f of x. And f of 1 is going to be 7 times 1 minus 2, which is 7 minus 2, which is 5. And now we want to plug g of x, 1 into g. And so we get 2 times 1 squared minus 1, or 2 minus 1, which is just 1. And so f of 1 is 5, g of 1 is 1, and so f plus g of 1 is just 6. And now let's do the same thing for these next three, and I'm going to go to another page. So we have f of x is 7x minus 2, and g of x is 2x squared minus x. And we want to find f minus g of negative 3. So we want f minus g of negative 3. So that's f of negative 3 minus g of negative 3. So we're going to plug negative 3 into both functions. F of negative 3 is just 7 times negative 3 minus 2, which is negative 21 minus 2, which is negative 23. G of negative 3 is 2 times negative 3 squared minus negative 3. So that's 2 times positive 9, which is 18, minus negative 3, which becomes plus 3. And 18 plus 3 is 21. And so now we get f of negative 3, which was negative 23. G of negative 3, which was 21. And we get f minus g of negative 3 to be negative 44. We would then do the same thing to solve the next two. F times g of negative 1. F times g of negative 1, that's f of negative 1 times g of negative 1. And so f of negative 1 is going to be 7 times negative 1 minus 2, which is negative 7 minus 2, which is negative 9. G of negative 1 is going to be 2 times negative 1 squared minus negative 1, which is 2 times positive 1, which is 2 plus 1, which is just 3. And now to get f times g of negative 1, we're just going to multiply. Negative 9 times 3, and we get negative 27. Finally, we want to find f divided by g of 2. And so we have, once again, f of x, 7x minus 2. G of x is 2x squared minus x. And we want to find f divided by g of 2. And so that's f of 2 divided by g of 2. Well, f of 2 is just 7 times 2 minus 2, which is 14 minus 2, which is 12. G of 2 is 2 times 2 squared minus 2. And so that's 8 minus 2, which is 6. 12 divided by 6 is just 2. So when you're given values for x, just plug them into the individual functions, and then use the name to tell you what operation to do. So for example, in this case, we had f divided by g of 2. We plug 2 into f, plug 2 into g, and then divide the answers. F divided by g. And we just get 2. So let's try another example. Very similar. We're just going to plug the numbers in and then just use the operations to tell us what to do. So in this case, we want to find, first of all, we have h of x is equal to x plus 3. G of x is equal to the square root of x minus 3. First, we want to find h minus g of 0. So h of 0 is going to be 0 plus 3, which is 3. G of 0 is the square root of 0 minus 3, which is the square root of negative 3. We can't take the square root of a negative number, so g of 0 doesn't exist. If g of 0 doesn't exist, then we can't solve this problem. And so h minus g of 0 just has no solution. So now let's do h divided by g of 3. Well, h of 3 is just 3 plus 3, which is 6. G of 3 is the square root of 3 minus 3, which is 0. Now, h of 3 divided by g of 3 it's going to be 6 divided by 0. And now we can't divide by 0. So once again, no solution. So be careful that when you plug these numbers in that you are able to get numbers you can work with. If you get something that's a negative under a square root, well, you can't solve that. And because you can't solve that, there's no solution. If you get something where you divide by 0, well, you can't solve that. And because you can't solve that, then there's no solution. Moving on, right? When no values for x are given, then we just need to perform the operations on the functions themselves. In this case, just some important notes. Make sure you always add your like terms where possible. Remember that when you're subtracting functions, to always distribute your negative sides. And remember to always FOIL, right? First, outside, inside, last, whenever you're multiplying. And always keep in mind you cannot divide by 0. So, given f of x and g of x, let's just determine these functions. We've got f of x is 7x plus 5. G of x is 3x minus 9. We first want to find f plus g of x. Well, f plus g of x is going to be f of x plus g of x. The brackets in the next part will be unnecessary. I'm just using them to show you where the pieces go. So f of x is 7x plus 5 plus g of x is 3x minus 9. Now we can add our like terms. 7x plus 3x is 10x. 5 minus 9 is negative 4. And so f plus g of x is just 10x minus 4. We want to do the same thing when we subtract. F minus g of x, well, that's f of x minus g of x. So that's 7x plus 5 minus 3x minus 9. Now here when we subtract, the negative sign, the minus g of x, the negative sign will distribute to the entire function. And so we're going to get plus negative 3 and positive 9. And now we can just add. 7x minus 3x is positive 4x. And 5 plus 9 is plus 14. So f minus g of x we still have f of x and g of x, same functions. We now want to find f times g of x. And so that's 7x plus 5 times 3x minus 9. And so we want to FOIL this. The first term, 7x times 3x is 21x squared. 7x times negative 9 is minus 63x. The inside terms, 5 times 3x is plus 15x. And then 5 times negative 9 is minus 45. And so what we get is 21x squared minus 48x minus 45. And finally, to determine f divided by g of x, that's f of x divided by g of x, which in this case, 7x plus 5 divided by 3x minus 9. There's no reason to simplify that answer any more than that. Now we can find the domains of these functions, of the sums and differences, products and quotients. The first thing to do is to determine the domain of the given function. Determine the domain of f and g independent of each other. Remember our rules for finding domains. You can't divide by 0, and you cannot take the square root of a negative number. Refer back to section 1.2 if you're try to remember how to find the domains of functions. Once you've found the domain of each function, the domain of the overall of the sum or difference of the product or quotient, that domain is going to be the intersection of the two functions individually. And what that means is what numbers do the two domains have in common. So find f of x, find the domain of f of x, find the domain of g of x, and compare the two. Whatever numbers they have in common, that's the domain of the overall function. The only exception to that is when there's division involved, you have to check the denominator and make sure you exclude the term that will make the denominator 0. So let's try this. We've got two functions, and we want to determine f plus g, f minus g, f times g, and f divided by g. And as we go through, we're going to determine their domains. So the first thing we should do is let's find the domain of f of x, which is 7x squared minus 4x plus 2, and the domain of g of x. Remember that when you're looking for the domains of functions, can't have 0 in the denominator, can have a negative under a square root. If we look at these two functions, there are no denominators, there are no square roots, and so the domain of f minus infinity to infinity, and same for g, minus infinity to infinity. So we have the domains for each of our functions individually. So to find f plus g of x, we're just going to say f of x, f plus g of x is just f of x, so 7x squared minus 4x plus 2, plus g of x, which is just x cubed. There are no like terms, and so we just get x cubed plus 7x squared minus 4x plus 2. Similarly, f minus g of x is just 7x squared minus 4x plus 2 minus x cubed, f of x minus g of x. Once again, no like terms, and so we just get negative x cubed plus 7x squared minus 4x plus 2. Now we can look at these two functions individually. If you look at f plus g of x, right, this is f plus g of x. Notice that there's no denominators, no square roots. So the domain, all real numbers, minus infinity to infinity. Same thing for f minus g of x. No denominators, no square roots, so minus infinity to infinity. So we can determine the domain usually in one of two ways. Either determine the domains of the individual functions, and then look for what they have in common. In this case, they have every number in common. Or we can determine the functions, f plus g and f minus g, like we did here, and then just look at the functions overall and determine the domain in that way. Let's do f times g of x. And so we have f of x, 7x squared minus 4x plus 2, and g of x is just x cubed. And so we want to do f times g of x. And so that's 7x squared minus 4x plus 2 times x cubed. Well, since we're multiplying, x cubed will distribute to each term. 7x squared times x cubed is going to give you 7x to the fifth. Negative 4x times x cubed is going to give you negative 4x to the fourth. And 2 times x cubed plus 2 x cubed. Again, we can look at this function. There's no denominators, no square roots. So the domain of f times g minus infinity to infinity. Finally, we can do f divided by g. And in this case, we just get f of x divided by g of x, which is just 7x squared minus 4x plus 2 divided by x cubed. Now, if we look at this function, we have a denominator. The domain for this function is going to be all real numbers except for whatever makes the denominator 0. Well, x cubed will be 0 whenever x is equal to 0. We have to leave the 0 out of the domain. And so the domain of f divided by g, minus infinity to 0, and then union 0 to infinity. So we've left out 0. So at the end of this lesson, you should be able to perform mathematical operations on given functions. That's adding, subtracting, multiplying, and dividing. And you should be able to determine the domain of the sums, difference, products, and quotients of functions.